Welcome. We're going to continue that talk and discussion and discovery of systems of inequalities. And today our inequalities are going to be written in standard form as opposed to slope-intercept form, just to spice it up a little for you guys. Again, our learning target, we're going to be able to represent and solve those systems of inequalities. And you know you are being successful when you can graph a linear inequality, which is in two variables. You can determine the solution of each one of those inequalities, which ultimately can then help you determine the solution for the actual system. And then you can justify some of your answers. So let's hop right into it today. So they want us to sketch the solution. So again, just like I said in the last video, when it comes to doing these for your assignment, you need to make sure that you are accurate as possible. The graphs on the worksheet are plenty big enough, or you can also do it on a piece of graph paper. If you don't have graph paper or a printer capability, you can pull these up on like your phone, a coordinate plane, and you can hopefully put them on there and screenshot it. You guys are resourceful. If you have issues, please let me know and we can come up with a solution for you. So ultimately on this problem, we need to sketch the solutions, and these sketches have to be accurate as possible in order for you to get credit for them, correct? Okay, just making sure we're all on the same page. All right, so the difference on these inequalities as opposed to those from the last video, the ones in the last video were in that slope-intercept form, right? They were technically in that y equals mx plus b form, where these ones are what are we consider to be in standard form, which is ax plus by equals c, right? So there's a couple different ways that you can go through and graph these. You can always turn them back into slope-intercept form, which is what we'll probably do on this first problem. And then on the next problem, it'll actually show you how to find x and y intercepts in order to graph. So the first thing we need to do on our little problems is we need to be able to graph the lines and then to be able to figure out what our shading is for the inequalities. So let's just start right off with this very first one. So our first inequality is that 3x minus y is less than -1. So right now it's not in that slope-intercept form, so we might have a difficulty time graphing it. So I'm going to convert it over into slope-intercept form, which is ultimately just solving it for y, right? So you need to get y all by itself, and you need to be able to move everything else over to the other side of the inequality. So to start that, I'm going to subtract 3x. Right, so negative y is greater than negative 3x minus 1. And then now I need to divide by -1 to get y all by itself. And if we remember, when it comes to inequalities, anytime you multiply or divide by a negative, it actually flips your inequality. So when I divide everything by -1, my y is then going to become less than 3x plus 1. And then now I'm in that slope-intercept form, so I can go ahead and graph it. My y-intercept is going to be 1, and my slope is going to be 3, right? So we had our 1, and then I'm going to go up 3 from my intercept, 1, 2, 3, into the right one, or I could go down 3 into the left one, right? Yes, either way. Any 2 points makes a line. And then I can go ahead and make this line, and I need to make sure I know if this is going to be a part of the solution or not a part of the solution. And it cannot equal y, so it cannot be part of the solution. So we denote that by making it a dotted or a dashed line, right? So that would be my first inequality. Now I just need to shade. So in order to shade, I'm going to look back at I'm just going to go back to where I had it in slope-intercept form. You can either put in a value, or you can just sit there and y is less than the rest of the line. So I'm going to look to where I cross the y-axis. I know y has got to be less, so I know it's got to be underneath. So for this inequality, my solution would be everything below the line, right? All right. So now let's look at our second inequality. So the same thing, it's not in slope-intercept form. So I had x plus y is less than or equal to -3. To get it into slope-intercept form, I just need to subtract x from both sides. And I'd have y is less than or equal to -x minus 3. So I need to graph my line. So I'm going to go down to -3. And then my slope is -1. So I can go down 1 and to the right 1. Or I could go up 1 and to the left 1, right? Either way. I need to find out if it's a solid line or a dashed line because it can equal it. It is part of the solution set. So I know then that it's going to be solid. And drawing as accurately as possible on the slippery iPad screen. And then now I need to figure out my solution set, right? So y has got to be less than. So I'm just going to come over here. Y is less, so it's going to be the below. So my solution for the green inequality is going to be all of this below, right? Beautifully drawn. So now in order to find my solution for my system, since a system is two or more inequalities, it is where they are both true. So when I look at this, I need to find out where they are both true, and they are both true in this part down here at the bottom, right? So I'm just making sure I color that a different color, shading it in darker, making sure that I as the teacher, or that you are showing to me that you know that that is the solution to the actual system, right? Word of advice, I would go through. I know sometimes we struggle a little bit when it comes to graphing these, is to always look at these. Like my slope is positive for this orange inequality. Is that a positive slope? Yep, it's going up. On this one, I have a negative slope. Double check, make sure you're having that negative slope in there. I got a joke for you. I can't resist. Do you know why the student ate his homework? Anybody? Because his teacher told him it was a piece of cake. I thought it was funny. All right. Example number 2. I'm trying, guys. I'm trying. All right. So on example number 2, we have these two inequalities, right? These two inequalities are not in slope-intercept form. That top one is definitely in standard form. So I'm going to look at this top one. This 2x plus y is less than -1. And the other way you can graph these is by looking at x and y intercepts. So I just wanted to give you guys an example on that. So if I want to find my x-intercept, by definition, x-intercept is where it intercepts the x-axis. So it's where it crosses the x-axis. And I know that when I cross the x-axis, I will always know that my y value is 0, right? So if I want to figure out my x-intercept, I'm going to plug in 0 for my y. So 2x plus 0 is less than -1, right? 2x is less than -1, so x is going to be less than -1 half. So I know that when it comes to graphing this, that my line has to intersect at -half. So I know that that's 1 point on my line. Using that same theory, I can find my y-intercept, right? Definition of y-intercept is where it crosses the y-axis. And if I'm crossing the y-axis, my x value is always going to be 0. So I'm going to plug 0 in for my x after I get to the pen. So 2 times 0 plus y is less than -1. So y is less than -1. So where am I going to cross the y-axis? I'm going to cross the y-axis at -1, right? Any 2 points make a line. So I know I can make my line, and I just need to decide if I'm going to make a solid line or a dotted line. And because I am not equal to, I know I'm not a part of the solution. So I know that I'm going to be a dashed or a dotted, right? So I'm going to be a little dasheroo. right? So now I just need to figure out where I want to shade this, if I want to shade it above or below. So here's an example of like testing a point. So I like the origin. It's nice and easy because the origin is 0, 0, right? So as long as my line doesn't go through 0, 0, I can always test it. So I'm going to plug in 0, 0 into my original equation and see if it comes out to be true or false. So I would have 2 times 0 plus 0 is less than negative 1. So on the left, I'm going to get 0 is less than negative 1. So I need to decide, is 0 less than negative 1? No, it is not. So I know that that is not true. So if that's not true, that can't be part of my solution. So since 0, 0 is not a part of my solution, I can't shade it. So that means I got to shade the other side of the line. So that means for that first inequality, everything on here would be the solution, right? All right. Let's try our second equation or inequality. Y is less than negative 3. Y is less than, how about a positive 3 today? Y is less than 3. So if I know y is less than 3, I know if anything, I got to cross at 3 where y is 3. And then I just got to make the decision, is this a vertical line or is this a horizontal line? I hope by now we can recall that this is going to be a horizontal line, right? And then because it cannot equal, we know it's not a part of the solution. So this would be a dotted line. And then now I just need to figure out if I need to shade above or below. And this is saying that y is less. So from here, where is y less? Y less is below. So for that inequality, all of this would be my solution for y is less than 3. So for me, I still need to make sure that I know what my solution is for my system. And so that would be where they are both true at the same time. So that would be where they are both colored. And they're both colored all the way from here through here, right? So this good old little chunk down here below is going to be my solution for my system. I hope you guys enjoyed these videos. Give me some feedback. Let me know what you're thinking. How am I doing? How am I not doing? Give me some advice on how to improve these. I'll talk to you later. Bye.